My wonderful fans, today we are going to be talking about photoelectricity in physics. If today is the first time that you're coming across my video, please do well to follow me on Facebook, subscribe to my YouTube channel. Thank you. Today we are going to be talking about photoelectricity. I'm going to be talking about photoelectricity. Under photoelectricity, what we are going to understand in that place is this. We are going to understand the concept of what? Solar energy. You know what? There is something that we do call photo cell. Okay, it's just a device that converts what? Solar energy into what? Electrical energy. These are some of the things that we are going to be learning in what? Photoelectricity. If you have solar in your house, you can understand it better because we use solar to explain everything about what? Photoelectricity. Number one thing is this. We are going to understand what is what? Photon. What is what? Quantum. Quantum. And what is what? Phenon. Phenon. These are the things that we are going to understand. What is photon? If you do not call it photoelectricity, you call it what? Light what? Electricity. Do you understand what I'm saying? If you do not call it what? Photoelectricity, you call it what? Light electricity, because photo is what? Light. So we are about to discuss what? The part of physics that has to do with what? Light what? Electricity. What is photon? Photon is just a what? A discrete of what? A discrete of what? Light is a discrete. Is a discrete of what? Or packet of what? Or packet of what? Packet of light. You don't understand what I'm saying? What is quantum? It's just a discrete of what? It's a discrete of or packet of what? Energy. Energy. Discrete or packet of what? Energy. Or packet of what? Energy. 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 Okay? What is phonon? Phonon is just a discrete or packet of what? Heat. Okay? But phonon is also known as what? A quiz of particles. It is also known as what? A what? Quiz of what? Quiz of what? Particles. Quiz what? Particles. But what is phonon? Phonon is just a what? Is a just remove energy and put what? And put heat. Is a what? Is a discrete or packet of what? Heat. Did you understand me? That means in phonon you are going to understand what we call what? Thermal. Thermal what? Thermal energy. That is heat energy. You don't understand what I'm saying? Let's continue. The question now is this: what is photoelectricity? Photoelectricity is just what? Emission of what? An electron. Emission of what? An electron. That is why if you are watching videos on YouTube, you need to you need to have what? Your jotter, so that you can jot many things down. All these things that we are teaching online, some of them you can't see it in your textbook. So we have to do research before teaching it online. Do you understand what I'm saying? Oh yeah. What is photoelectricity? Photoelectricity is just the what? Emission of an electron from a surface of what? A metal. It's not thermic emission. Thermic emission will emit, the electron will be at the surface of what? Hot metal. Do you understand what I'm saying? So photoelectricity is just emission of what? An electron from a surface of what? A hot metal. Where incident light. Where what? These are the concepts that you are going to understand. Where incident light, such as ultraviolet ray, such as what? Ultraviolet what? Ray or visible light is incident on the what? On the surface of the what? Metal. Where incident what? Where incident light. Where incident what? Light. These are the key that you are going to see there. Or what? Ultraviolet. Where incident light, ultraviolet ray, or what? Visible what? Visible light is what? Incident on the what? On the surface of what? Of the metal. Do you understand what I'm saying? So these are the what? The concept that you are going to see there. The next thing is this. Look at, let me draw what I just explained now, so that you understand it. Look at, this is the surface of a metal. Let's assume that this is the surface of a metal. Let's assume that this is the surface of a metal. This is the what? Where what? Incident light, abi? Such as what? Uh, such as what? Ultraviolet what? Ray, abi? Is what? Incident on the metal. This is just, let's take this as the surface of the metal. Let's take this as the what? Metallic what? Surface. As the metallic surface. Okay? Let's take this as the metallic surface. From our definition, that means this, we say that where what? Incidents like such as what? Ultraviolet ray. Let's say that this is an ultraviolet ray, or what? Visible light. Is what? Incident and the metal. During that time, there is what? Emission of an electron. Let's say that there is what? Emission. That means there is what? Emission of what? An electron. Let's say that this is the what? Electron. This is the electron. So in photoelectricity, the concept there is that there is a what? Emission of what? An electron. Do you understand what I'm saying? So when you are studying it, look at what you are going to see in that place. If you see solar in your house, if you guys have solar, if you watch your solar, you know they have solar panel. That is where the electrons are being what? Emitted. Do you understand me? That solar panel is what we call what? The metallic what? Surface. The sun, the sun, which we do call solar energy, which converts what? Which under photo cell, you said that it is what? It is a device that converts what? Photo cell that converts solar what? Energy into what? Electrical energy. These are the concepts that you are going to see there. Oh yeah, let's, for JAMB students, there are two things that you need to know about this topic. The first one is this. The first one is number of emitted electron. Number of what? Emitted what? Emitted electron. Number of emitted electron. The second one is what? The kinetic energy. The kinetic what? Energy of the what? Emitted what? Electron. Of the what? Emitted. Of the emitted what? Electron. Emitted electron. Electron. The number of what? Emitted electron depends. For JAMB student, you have to bring out your jotter and jot this thing down. For number of what? Emitted electron depends on the what? The intensity of the what? Of the incident what? Light. Depends on the what? Depends on the what? Intensity. On the what? Intensity. Intensity of the what? Of the emitted electrons. Emitted what? Electrons. Okay? Why the kinetic energy of the emitted electron depends on what? On the what? Number of what? Depends on the what? On the wavelength. On the wavelength or what? Or frequency of the what? Emitted what? Electron. Or frequency of the what? Emitted what? Frequency of the emitted what? Electrons. Emitted what? Electrons. Okay? For JAMB student, you have to note this thing. They do ask this particular question. They will now ask you, the number of emitted electron depends on what? In the option, you see many things there. First one, you know that the number of emitted electron depends on the what? The intensity of the what? Of the incident light. Hey. Depends on the what? Intensity of the what? Incident what? Light. Incident light. Okay, still the same thing with this. Incident light. Okay, so the next thing that you are going to understand is this. What is let's continue from where we stop. For you to solve photoelectricity, Max Planck constants, Max Planck law and Einstein's law are being applied in that place. That means the both work in accordance. Let's continue. So we are going to understand what we call what Max Planck what constants, Max Planck what law, and what and about Einstein's law. About Einstein's law. About Einstein's law. First of all, we have to go with what Max Planck's what constants. Max Planck's what law. Let's continue. Max Planck's law. Max Planck's law creates what the relationship between what energy and what frequency with respect to what its own what constant, which is what the Max Planck's constant. We are going to reach at the law states that the energy of the what electromagnetic what radiation, that is what Max Planck law states, that the energy of the what electromagnetic what radiation is directly proportional to what to its what frequency. Did you understand me? So the energy of the what of the electromagnetic what radiation is directly proportional to what its what frequency. That means if we remove this proportionality sign, the energy now will be equal to what h what f. Did you understand what I'm saying? In quantization energy, in quantization in physics, we can even remove this energy. The energy can be equal to the energy of the what excited what state minus what energy of the what minus what the ground what energy. Did you understand me? So you can still remove this. You can still remove this and put this. So this can be in this form minus this 0 equals to what h what f. This is what the Max Planck what law. We have explained it now, where E is what energy of the what radiation, and F is the what is the frequency, while H is what is the Planck constant. Planck constant is equals to what 6.63 times 10 raised to power what minus what 34 joule what seconds. This is the unit. This is for Planck what constant. Do you understand what I'm saying? So you have to go carry your jotter and put all these things down. Let's continue from where we start. I think we have to solve questions that have to do with this. You know, in wave, we say that frequency, we say that velocity is equals to what? Is equals to frequency lambda. So velocity, so frequency will be equals to what? Velocity all over what? All over lambda. We can still remove this velocity, which is still the same thing as what? The speed of light. You can still remove it and put c all over what? All over lambda. You don't understand what I'm saying? So if that is true, let's know what we can do now with it. Let's know what we can do. Let's check. Before we said that initially we said that energy of the emitted electron is equal to what? Hf. Oh yeah, if F is equal to C all over what? Lambda. That means we can still remove, F and attach this. That means energy will be equal to what? H what? C all over what? All over lambda. And we can still remove this this energy, because we say that energy is equal to what? Energy of the what? Excited state minus what? Energy of the what? The ground state. Okay? If you remove it and push the whole of this, it will now be this form. Energy minus this O is equals to H what? C all over what? Lambda. And we note that C is equals to what? 3 times what is the speed of light? 3 times 10 raised to power what? 8 meter what? Meter per second. Because it is the same thing as what? Velocity. We are talking about speed of light. Why H? Like I told you before, that H is equals to what? 6.63 times 10 raised to power what? Minus what? 34 joule what? Joule seconds. Okay, do you understand what I'm saying? These are the what? The things that these are the what? The parameters that Max Planck used to explain his law. So we have to solve question. I have to do with this particular, or when I'm done with about Einstein's law, we can still go ahead to solve question there. If you have not subscribed to my YouTube channel, please do well to subscribe and follow me on Facebook. Thank you. And let's continue from where we stop. What is photocell? Photocell is what? Is a device that converts what? Solar energy into what? Electrical what? Energy. That is the meaning of what? Photo what? Cell. So uses of what? Photocell. We use photocell in the what? In CCTV camera. We use photocell in the CCTV camera. What is CCTV camera? CCTV camera means closed what? Closed circuit television what? Camera. Closed circuit television what? Camera. That's the reason why if you see all this CCTV camera, they do connect it with television inside the house, or you can still use your phone self to connect it. CCTV what? Television what? Camera. Okay. We use it also in a burglar alarm or in a door control mechanism. These are the places that we can use it. We can still use photoelectricity to generate what? To generate light. Okay, a generation of what? To generate light. That's what I mean. This if you go further, you can still find the uses of it more. You can still get more and put down for WAEC students. Do you understand what I'm saying? Let's go further to today we are going to finish this topic. Let's go further to Albert Einstein's what? Law. So Albert Einstein says that Einstein's law. Albert Einstein says that the kinetic energy, the maximum kinetic energy is equal to what? HF minus what? WO. This W naught is what we call what? Threshold what? Frequency. Threshold what? Frequency. Threshold work function. This W is what we call what? Work function. Okay, but someone asked question. Someone asked about Einstein that time. There is a question that the guy asked a man. He then look at what he asked. He said, how would photoelectricity occur? But about Einstein told the guy that photoelectricity can occur when HF is what? Is greater than what? Work function. Do you understand this now? When what? HF. This H here is what? Planck constant. While F is what? Frequency. When HF, the product of H and F, is greater than what? Work function. What is work function? The minimum amount of what? Energy required to do what? To liberate what? Electron from the surface of what? The metal. The minimum amount of what? Energy required to liberate what? Electron from the what? Surface of the what? A metal. That's what we call what? Work function. So when HF is greater than work function, you know that photoelectricity can do what? Can occur. So W naught is equals to, let's continue from where we stop. Let me make a space. If kinetic energy, maximum kinetic energy, is equals to HF minus what? Work function. And I told you guys that work function is the minimum amount of what? Energy required to liberate electron from a surface of